Okay, welcome back. Hope you were able to meet a few new people and discuss some new collaborations. We're getting ready to hear from a panel that Dennis spoke about a little bit this morning, the Platform for Advanced Wireless Research. This is a really exciting new initiative that is kicking off here in the region, and it really was born out of the collaboration that we talked about before. The best collaborations are the ones that are extremely diverse in makeup, and I believe Dennis said there were over 70 different organizations that were involved in this, but also ones that are very inclusive in participation, and I think that'll come through as we hear from this next group. I'd like to ask Terry Yates to come up to the microphone and introduce the panel to talk about AERPAW, this new advanced wireless network for drone research. So Terry.
Good morning, everybody. Thank you all for being here this morning. My name's Terry Yates. Also I want to thank NC State University, Riot, City of Raleigh, for having this great event at this facility, great facility. Also wanted to thank the National Science Foundation and US Ignite because without them we wouldn't even be having this session. So we really appreciate this opportunity, and I appreciate the opportunity today to come out and talk about this exciting program and platform that is really truly a regional collaboration. I'm the Cary Smart City Program Manager. I've had the fortunate privilege of being in local government for 27 years. I've been 18 years at Cary, and it is just amazing really to see how this region is growing. Nicole said, there is lots of people that want to collaborate, and it's just so exciting. And I never would have thought that that I would be in this position 3 years ago. As Nicole mentioned, my position didn't even exist 3 years ago. With this panel, I'm going to be moderating it with my esteemed colleagues. And really, I'm going to be kind of representing on the municipal side, me and my colleague Noah Otto for City of Raleigh. We've really been kind of focused on the municipal side of this effort. So with that, I'm going to turn it over to the panelists. I'm going to let them introduce themselves and talk a little bit about what their role has been on this panel.
Hi, everyone. I'm so glad you all could make it. I'm Silbey. I am the Director of Communications for US Ignite. We're a nonprofit 501(c) based out of Washington, D.C. And importantly for this audience, we are the co-lead for the project office that manages the Platforms for Advanced Wireless Research program, of which the new AERPAW testbed is the latest platform and testbed to be announced. So much more to come on that front.
Hi, everyone. I'm Ismail Guvenc. I'm an associate professor in the Department of Electrical and Computer Engineering, and I'm the project investigator. We are very excited to be here. I'm representing the rest of the team, and we have Gerry, also part of the team. I'm looking forward for the panel.
Hey, good morning. Good morning. I'm Darshan Divakaran. I'm the U.S. program engineer for the North Carolina Department of Transportation's the U.S. program that's drones. And for us, we are the users. We would love to test this technology and help the state grow from a research point of view and also from the economic development point of view.
Good morning. I'm Gerry Hayes. I'm the president and founder of the Wireless Research Center. It's a 501(c)(3) organization in the town of Wake Forest, founded 9 years ago with a unique blend of advancing communication technologies and economic development. And we're a co-partner with NC State and AERPAW, and we're excited to be here. So thank you.
All right, so we're going to get right into the questions. Mari, can you tell us about this program and really why this region was selected for it?
Yeah, I'm going to try not to go on and on because I really could talk for probably hours on this topic. It's the Platforms for Advanced Wireless Research program. I won't say that again. It's PAWR is the short acronym, PAWR. And the program is a $100 million public-private partnership initiative that is funded in part, half, about $50 million from the National Science Foundation, so that's federal grant money, and then another $50 million in cash and in-kind products and services from a consortium of 30 wireless industry companies, associations, organizations, and that includes the major wireless carriers, it includes all of the major equipment providers, software providers, so all the people in commercial industry that are really important to determining what happens next in advanced wireless technology. Now, the purpose of the program is that we are deploying city-scale wireless testbeds for research, specifically to understand what we can do next in 5G networks, but also beyond 5G, so that we can enable next-generation applications, so that we can optimize how networks perform, and so that we can continue the US wireless leadership that we have today, and also, while also generating new economic opportunities. But what does that mean? Probably everybody in the room has heard of 5G because it is such a big marketing term at this point. That's really what it is, it's a marketing term. If you think about it a little more deeply, 5G is just a basket of technologies, everything from tech that's used to work in new spectrum bands, to doing things in software that we used to do in hardware. There's a whole basket of technologies that are part of that. And what we're trying to do with these city-scale test beds is really look at all of those different technologies and see how they can be tested and improved upon and innovated on in a real-world outdoor test bed environment. We have 2 city-scale test beds that are deployed today, as was mentioned earlier by the Vice Chancellor. There's one in Salt Lake City, Utah, and one in the West Harlem neighborhood of New York City. And the purpose of those 2 platforms, which were both named last year, was really to look kind of deep in the network stack. So really sort of, the deep, gorpy underpinnings of how networks work. And as we looked at the 3rd test bed that we wanted to deploy, we went through a very rigorous RFP process. And part of the requirement when we selected AERPAW is we wanted a new test bed team to come to the table with not only the wireless communications research perspective, but also an application or use case that would be relevant to solving challenges in communities. So again, it was a rigorous, very rigorous application process, and it speaks to the AERPAW team's research and academic credentials, a lot of work that went into this, but I also cannot emphasize enough, as everybody else has done, the importance of the collaboration that went into making the proposal a successful one for the deployment of AERPAW, and that means all of the associations. It means the Wireless Research Center, it means the NCDOT, it means the town of Cary and the city of Raleigh, and many, many others. That was such an important factor, in addition to the incredible researchers that are part of the team, that was such an important factor in choosing AERPAW, which will start to go into design and deployment over the next year.
All right, thank you, Mari. That was great summary. And one thing I want to say, thanks to Ismail for putting this graphic together, kind of overview of everything. But kind of dig deeper into this graphic about who all is involved in this, in the platform, where it's going to be deployed, how soon it'll be deployed. Can you give us some specific details on that?
Sure, definitely. So as you can see in this slide, and as Mary mentioned, this has been really a team effort. So this is led by NC State University, but we have very critical partners that we are working together. Wireless Research Center is our deployment and operations partner, and Mississippi State University is one of the big collaborators. We will actually have a small portion of the platform will be deployed there. RANSI is our software development partner from UNC Chapel Hill, and Purdue and University of Southern Carolina, they are going to be integrating some of their solutions. And we obviously have Raleigh, City of Raleigh, Town of Cary, and NCDOT. They are our municipality partners and drone partners. There are very exciting things happening in all those cities, and with NCDOT, their integration pilot program, maybe Darshan may talk a bit more. So this is a very exciting team, and we have many other partners that you don't see in this chart. that we will be collaborating with. We have more than 30 companies in the PAWR consortium that are where US Ignite and PAWR project offices working with. We are pulling some equipment. So this is $24 million. $50 million is coming as in-kind equipment and service contributions from major 5G companies, all the operators and vendors. So you can see the map here on where we are going to deploy what at a high level. It's a very diverse environment. So we are starting from the Centennial campus in NC State. We will have many software programmable radios, which we can program as 5G base stations or IoT equipment or anything. So this is not really constrained to 5G, but it's anything advanced wireless we will be offering with software programmable radios. We will have equipments from Ericsson, like base stations, IoT equipment. And Centennial campus, that's where it starts with part of city of Raleigh. Then Lake Wheeler farm, a bit south of Centennial campus, is where we are already flying drones. We will be expanding our drone experiments, working with the other College of Agricultural Life Sciences faculty. There is a big potential in smart agriculture. Basically, we will be working with some partners on that. And there is Town Oak Cary. Starting from year 2, we will start deployments in Town Oak Cary. Timeline, by the end of year 1, NSF and the PAWR project office, they have a very strict timeline we have to meet, so we are working towards hitting those deliverables. By the end of next summer, we will open the platform with some basic functionalities for outside experimentation. We are planning to have a summer event in August where people can come and test and get trained on the platform. And within the year 2 and 3, we will deploy much more nodes. So by the end of year 1, we are going to have 2 fixed nodes in Centennial campus and 1 fixed node in Lake Wheeler. A lot of other things are going to happen in the background with the software infrastructure, control framework. But years 2 and 3, it will be a very aggressive plan, at least 10 nodes in each year. And what we are really going to offer is what you see on the right-hand side of this screen. So the users will be able to, from their office, they can run some experiments on 5G. There will be operators who are controlling this to make sure that they are not transmitting out of band. There will be pilots on the ground. On the Lake Wheeler, you can see they're flying the drones with necessary training. So we plan to be fully operational by the end of the 3rd year. And we will support mobility experiments, drone experiments. It will not only be drones, we will also have nodes in shuttles and cars. And we will have rural, suburban, and urban type of experiments. And eventually the goal is reliable, software programmable, remotely accessible platform by the end of the 3rd year. And years 4 and 5 are mostly operations, and we will be hopefully self-sustainable after year 5.
All right. That's great. For one, as a municipality, and Nicole mentioned this, we have a not only NC Engine Drone Committee, but a Town of Cary Drone Committee. We were fortunate enough, with the support of our staff and our council and administration, to get 6 drones as part of our budget. And so we are really excited from a municipality standpoint. We've got a lot of things we want to test out, a lot of ideas. So, it's really great to know that, we're going to be doing over the next several years, it's really going to gain speed and accelerate. So with that collaboration and everything, I'm going to turn it over to Darshan about NCDOT and what you guys are doing in this space, and how you see this platform helping, and some other things around that.
Sure. The one thing, we are in the forefront of great innovation and technology, and North Carolina, as in the last couple of years, been in the forefront of unmanned systems. For us, the important thing is how do we see the full potential of drones. And we're not talking about just the simple small drones that takes photograph and video, but most recently you read the news about the medical package delivery, UPS getting their waiver to fly. And this is also going to the direction of food delivery. disaster response, during disaster, having resources delivered. It's moving in a level where we are talking about the future of urban air mobility, where you're going to have vehicles that can take larger cargo, people, and how do we get all these things, successful? One of the biggest hurdle for us and for the whole nation really is beyond visual line of sight operations. And for the success of beyond visual line of sight operations, you have to have connectivity, and you need to know where your drone is at every time. You need to know if your drone is able to communicate with other aircrafts in the airspace. We are, when I say we, I mean the drone users. We are, using the airspace that really does not yet belong to us. It belongs to traditional manned aircrafts. It belongs to you have your sport vehicles, you have your balloons, you have skydivers, you even have birds that are flying. You have so many users, and we are just, getting into the airspace and expecting to go beyond visual line of sight, do operations, and this is where connectivity plays a big factor. For NCDOT, we have been working closely with our state partners, our private partners. We are big for public-private sector collaboration. And the great example is last year's Hurricane Florence, where we responded. It was a public-private sector collaboration. The success of any innovation technology cannot be just one group, maybe the public sector focusing or the private sector focusing. And it's history always that the private sector has better resources, better technology, but it's the public sector that have more ideas, more usage, and collaborating. This is where a great example is this research project, and we congratulate NC State University and the Wireless Research Center and all the other partners who worked to get this to North Carolina. We have the history of first in flight, and drones is what is the next, the frontier of aviation. You have your manned aviation, unmanned aviation, and we are the next frontier of that. So biggest use for North Carolina DOT, one is the integration pilot program. We have partners, UPS, Matanet, Zipline, Flightrex. They're all in the news right now because they are doing something which has never been done. And it's all happening in North Carolina, and Federal Aviation Administration is working with us to make this a reality. But we all have roadblocks. And again, that comes back to the topic of connectivity. So with that comes disaster response. We have to respond at a state level. One side is coast and one side is the mountains. So you don't have really a perfect weather, or you don't have a terrain that you can say, this is what we need to fly, and it's easy to fly. So there is dead zones when we fly drones, and we need to realize that. We know that, but we don't know how to resolve it. And through this research, we could use this more. We could get the technology to the right people quicker. And then comes NCDOT's traditional usage, that is infrastructure inspection. All the roads, rail, airports, all maintained by us. And when we maintain it, you have routine inspections. Some of these inspections have to be done annually, 6 months, and it is dangerous. It's human life. It is time, money, a lot of things is taken into effect. And if we bring the drone technology into this, it really helps, speed up the process. But again, it comes to the point of when is it possible to get into the beyond visual line of sight? When is it comfortable enough to fly over people? All these things are together, connected through some way this research can help. And you may not have the solution, everything right now, but it's the direction that we are going in. And if North Carolina can provide the solution to the whole nation, we are really excited about it.
All right, thank you. I think it's a great point, and it's kind of the summary of this whole conference is about collaboration. We talk about smart cities. Noah and my colleagues in this, smart cities is kind of a buzzword. We like to think of it more of smart and connected communities. And I think having the DOT as part of that, having NC State, Wake County, it's smart and connected communities. It's not just cities, it's the community. And so kind of along that theme, I'm going to ask Gerry here, what are some of the benefits that our smart and connected communities can really take advantage of with aviation programs such as this?
Sure. One of the things to think about is, we've talked a lot about communications and the robustness of the communications. And what we're doing with AERPAW is we're taking it from 2D terrestrial and including the third dimension to that. And therefore, like drones, urban air mobility, transport, all becomes part of that ecosystem. It becomes part of that smart connected community. And then, as we mentioned, the drive is for applications that'll solve issues today, increase our efficiencies on a commercial level, on a community level as well. We talk about first responders. One of the things that we look at is a defibrillator to go treat a cardiac arrest. It's an 8-minute response time on average. With a UAV defibrillator, it would reduce it down to 3 minutes. That translates to saving lives. So there's a lot of benefits there on the health and services. With the IPP is blood transport between two regions. You can extend that to transporting medical staff. And in times of a crisis, they're not going to be limited by road floods or blockage. It can be the fastest means of getting a response time there. On a commercial side, we're looking at right now package deliveries and efficient coordinated package delivery. So those are some of the first areas that we see, and then we see on the application side, once you have this tool out there and available, that's where the magic happens, and that's where it happens, with IoT and with the Riot community building on that. It's really up to the imagination of how do we solve the problem with the tools that we have. Our goal is to make sure that those tools are robust and to make sure that they're secure. We always assume positive intent, but you also have to be robust enough to handle a negative intent on that as well.
All right. Well, that's great. So NC State has really been kind of the coordinator of all of this effort, and we appreciate all that work on that. But the municipalities and the smart connected communities are a big part of this effort, and so I'm going to turn it over to Mari and kind of explain why not just do these tests, with the universities, and they have large campuses. Why not do it at the universities? Why have communities involved in this as well?
Well, the universities are doing this work for sure. It's happening in a lot of universities and research institutions. It's also happening in labs in commercial companies. But the benefit of having an outdoor real-world test bed is you actually get to test these technologies in situations and facing the challenges that communities will face and looking at the problems that communities are specifically trying to solve. For example, the being able to transport blood to a victim that may need it very, very quickly. And the types of challenges we're talking about, there was a mention about like non-line of sight communications. There's, famously vegetation can be can certainly affect how radio signals travel and propagate. There is user strain, so just what happens when lots of users get on a network, and lots of users may not just be people anymore, but maybe lots of devices and other connected things. So that's really the importance of having that real-world test bed, and the program itself is really designed to help make that leap from the labs and from the academic research and the industry research that's taking place, helping make that leap faster from those innovation centers into actually commercially deployable types of technologies. So we want to reduce that gap between innovation and deployment. And the one other thing I'll say with the program is that as we're creating these city-scale test beds, we are also acting as a sort of center of gravity for new tools to come into this program that benefit the researchers that participate. So, for example, we announced just last month that the FCC has now designated our first 2 test beds in New York and Salt Lake City as the first ever innovation zones for spectrum research. And what that means is the researchers on these platforms, and that will include AERPAW as well, get much more flexible access to spectrum licenses to run their tests. So you can imagine as as researchers are looking at moving into higher spectrum bands, for example, as they're looking at doing spectrum sharing, suddenly there's a much more flexible way to get access to that spectrum to run those types of experiments. There's also DARPA has run a challenge recently called their Spectrum Collaboration Challenge, and they're actually going to do their championship event next week in Mobile World Congress in Los Angeles, if anybody is going to happen to be there. And these competitions, these challenges that DARPA has been running, has been to essentially drop in teams and have them participate in challenges in different spectrum scenarios, and then determine who performs best under those particular conditions. We're at this championship event next week. Well, after that program is done, the PAWR program is going to inherit all of the supporting infrastructure that supported those challenges and those competitions. So all of those software-defined radios and antenna arrays are now going to be hosted with our partners at Northeastern University in Boston. And again, that just becomes another tool if researchers want to do experiments and emulations on spectrum collaboration. Will be able to do that through the auspices of the PAWR program, run some of those tests, within the RF emulator that will be at Northeastern University, and then transition and take some of those tests and trials out into the field with these test beds. So as I say, it's really having the outdoor real-world environment is important, and then having a program that is collecting all of these tools to make it easier for researchers to do the research they need to do is really important. And I will just do a plug, by the way. We have many, many partners as part of this program, and if this is something you want to learn more about or get more involved with, please do come talk to me. You can also go to the PAWR site, which is advancedwireless.org, and you will see information about all of the test beds there, including AERPAW.
All right. So, we've been talking about all these benefits and how great this is going to be. Darshan touched a little bit on some challenges, but kind of going back to that, Darshan and Gerry, what are the challenges? What are the challenges you see with, UAV deployments in general and, this platform and everything?
So, aviation took over 100 years to become successful, but in the unmanned side, we are expecting it in less than 10 years. And that is the reality. Everyone's rushing. 2014, 2015, we just talked about drones. We talked about how the applications drones. By 2020, we're doing delivery of package delivery. And there was also, 2020, 2025, urban air mobility. We are rushing in the unmanned side in a pretty fast way, and people are losing patience. Companies are just coming and going because they realize there are roadblocks, regulatory roadblocks. FAA is also changing. The FAA has realized, that's the Federal Aviation Administration, they have realized that they have to move with time. So as they mentioned earlier, they no more their grandfather's FAA. They are now a young group which understands this technology has to stay, but they need data. They need data to prove that this can be a regular operation, and the data does not come if we hold on to it, if universities hold on to research, if public sector and private, public sectors like us are holding on to our research, and private sectors are also holding. We have to collaborate. Getting out of the, as mentioned, getting out of the universities is important. Real world test we need to do, because we're talking about real world operations. And this comes back to the point that if we want something to get successful in a shorter duration, we have to ensure safety. We have to ensure that we have all of our, operation standards met. As mentioned, it's not just moving from point A to point B and doing a package delivery, but also knowing that if there is a maybe you can call it a rogue drone, maybe there is another vehicle in the airspace, maybe you have a connection failure, what happens then? You're talking about package delivery of blood, which is a very valuable product, and it's important to move that from point A to point B to save lives, but you can't risk it unless you have the right solutions met. And that's where, for us, this research is a continuous work in progress. We can tell FAA that, okay, this is what we are doing in North Carolina, this is the data that's going to come out of this, can help educate FAA, can help educate other companies, and see how this can be a reality. UPS wants to do package delivery all around the nation. And FedEx, they are into it. You know, every other company, I would say every 6 months you'll hear a company or two coming in into this side because they realize that they are one step closer to making it a reality. So you have big names like Airbus, Boeing now looking into it. So I think this is where it comes back to is we are in the right time and we are doing the right stuff. And this initiative in North Carolina makes other states realize that we are not just talking about research, but we are talking about real world usage of this. So for us, we're just excited that we can be part of this. We can actually test this technology, and we don't want a disaster to happen, but next time a disaster does happen, it's an excellent test bed to actually use it and see the results and then pass it on to FAA and say, this can be done by anyone and by anyone and everyone.
Yeah, to kind of expand on that, there's several categories. There's the technology challenges, and that's what AERPAW is focusing on. There's the regulatory challenges of kind of taking, an existing agency and kind of bringing them forward with new capabilities and new technology. And then there's the community acceptance and community education, kind of educating smart cities, communities, what's possible, what are the challenges, what are the risks, what are the benefits, and then moving it forward and kind of accelerating that process. And working and collaborating together is the fastest way to do that.
All right, so I know there's communities in here that may not be a part of this, but now are like, I'm ready to get on this platform and start doing some testing, start doing some research. So I'm gonna turn it over to Ismail about how other communities can get involved with this.
Sure. So there may be various different ways that smart and connected communities can be part of the platform. The obvious one is you can become more users once we have the platform in place. So we will offer many different interesting experimentation possibilities, IoT, 5G, millimeter wave, Verizon and some other operators there, they have licenses in millimeter wave. They will be releasing also deploying in Raleigh area. By the way, one thing I realized I didn't include in this slide is our website, airpaw.org. So if you're interested to stay in touch, you can go to airpaw.org. We have our contact email. We have an email group that we will start sending some news every once in a while. So apart from that, we have our municipality partners, Town of Cary, City of Raleigh. We have started working with them to deploy, starting with year 2 mostly, some equipment. And the way that they contribute into platform is Cary, for example, Town of Cary, they are opening their towers. We will place some equipment there. So they are contributing to the platform, and they have some rights in the platform, with this contribution. So we have a very dense timeline in the first year at least, but we may, with consulting with the US Ignite and Project Office, we may be expanding this to other municipalities in the later years once it's more mature to deploy other equipment. And we are working closely with NCDOT as well. So in terms of industry, as Mary mentioned before, one possibility is to join the consortium. Again, the industry members, they contribute to the platform, and then they have some, this will be after a year or so, this will be a platform where once we are fully operational, we will start charging users. So once the communities contribute, they will have free access to the platform. Maybe they're still working on some token or some other approach to do experiments, but industries and communities who contribute, they will have some additional rights. And otherwise, we are also working with several other industry partners to deploy some additional equipment or in the software or hardware. If you're interested to discuss more, we are more than happy to talk more on that front as well.
That's great. You know, I was just sitting here thinking about how, you know, Nicole talked about how this region and state were collaborative, being smart and collaborative, way before smart cities. And we talk about, before I became a smart city program manager, I managed the radio system at Cary. And I just think about over the years, you know, we start talking about towers and doing co-location in space. I think about the work being done now with FirstNet. I think about, you know, all the collaborations on wireless communications with the carriers and everything. It's just funny how all of this is just kind of progressing, and you know, it really talks about the collaboration and how we've been, North Carolina's been that way for many, many years. So last question, I'm going to turn it over to Mari. You know, so you talked about a little bit how US Ignite is, you know, what you want to see out of this, but can you expand a little bit on that for the audience?
Sure, yeah, no, happy to. So as I mentioned, it really is about speeding up that process of getting technology from the lab out into real world and commercial deployment. It's instructive to look at the early test beds that we've named, that were named in 2018. The Salt Lake City one now is up and operational, and researchers are starting to run experiments on it. So again, you can think about the types of experiments that you might model in a virtual environment, and now you'll be able to take and run some of those experiments, and we're going to see how these things, again, perform in the real world. And that's everything from, you know, very, very specific technologies, very, you know, new open source operating systems used to orchestrate the, you know, new types of disaggregated radio hardware that's out there, which is an important part of 5G, but also wireless communications even beyond 5G. So you'll be able to test, we want to see what comes out of that in terms of what does that mean for performance, what does that mean for power draw, what does that mean for spectrum interference, all of these types of things. But then in addition, as we keep sort of coming back to as well, it's about what can you do with those new capabilities. So if you have lower latency or faster response times in networks, if you have more throughput, if you have faster speeds, or you have 100 times the number of devices connecting to a network than before, what does that suddenly enable you to do? And that is things like drone delivery and medical use cases, but it may also be virtual reality simulation experiments. It may be experiences. It may be precision agriculture. That was mentioned briefly as well. It's about figuring out once those platforms and those capabilities are in place, again, what can we do with the communities to actually solve particular problems that the communities are facing? Because really, I mean, my background is as a telecom reporter, so I do get very excited about the telecom and the technical piece. But when it comes down to it, the whole purpose is to figure out how to make our communities better. And that's really why we are bringing this technology out into the community, to try to combine those things and show that this is not just something that takes place in a lab and that researchers can write papers about and get excited about. It's about something that everybody can get excited about because it's ultimately going to improve quality of life.
All right. So now we're going to open it up to you guys, answer your questions. So who wants to be first? All right.
Will there be like controlled areas they'll be into, uninhabited, and then they'll start migrating out to the habitable areas? Because I look on that map there, it shows the person running has got all those grids. So I'm assuming they're hitting a grid in the areas, but I would imagine the first stages they will be basically low population areas, where I'll be looking over my head waiting for one of those things.
So we will have initial deployments in the Lake Wheeler area, and you can see the south of that map, a bit south of Centennial Campus, as far as drone experiments. So as I mentioned earlier, this will not be focusing on drones only. So all the nodes that we are going to have there, they may be communicating like fixed tower to fixed tower to an indoor node or a mobile vehicle. So those are some experiments we are going to have in all those areas. Especially with Lake Wheeler, we will start drone experiments from year one. And then we plan to be expanding Town of Cary, like Terry mentioned. They already have a drone working group. So we will be flying drones there as well. Centennial Campus, we will be working with our leadership, the south of the Centennial Campus to fly drones. But this map may change. This is like our estimate by the end of year 3. It may change a little bit during the process, but by the end of year 1, our plans are 2 nodes in Centennial Campus and 1 in the Lake Wheeler. So that's committed for year 1. And does that answer your question? Or?
Yeah, and just to add on to that, so in Cary, yeah, one of the things, and I kind of go back to my radio system days, a lot of agencies experience frequency interference, and it could be from a variety of sources. Carriers experience this, public safety agencies experience this. So one of the things, and it's really kind of a controlled environment, if we do experience that, we want to create some type of way that we could maybe fly a drone up and kind of look at the interference levels and see, can we hone in on that? We had real world experience probably 6 years ago. We were having really bad interference. We hired a helicopter. A technician went up with a spectrum analyzer, and we had spent a month trying to find this interference, and in 15 minutes we found it. Because once you get above the noise floor where everything's communicating, you can really clear the air and really find out where that's coming from. And I mean, that's a real world, real life thing that, I mean, Town of Cary, we're interested in. And I think other public safety entities are interested in. So just want to add on, and so that wouldn't really necessarily involve, flying to different locations. It's really just getting up in the air above the noise floor, So
maybe quick comment. So I was actually, when Mary was talking about going outside of university, I was thinking about this example. It's very exciting. So that's one of the nice examples. When you go beyond the university and the lab, you start interacting with communities and you go beyond your comfort zone, you find the real helpful applications. I think the universities, we have great research that we can offer to the community, and the community, if we can learn better about the use cases and applications, that brings a lot of value. Even within the same university, like we are now interacting with the College of Agriculture and Life Sciences for the smart agriculture, we are realizing there are a lot of synergies and collaboration opportunities. So that's great to work together.
Great. All right, next question.
So adding on to what you just said there, this is looking at an urban environment where you're going to have a fair amount of high level of 5G or whatever connectivity. When you get further away from the urban areas, especially I'm looking at the folks from the DOT, where you have areas of the state that may not have this sort of level of connectivity, are you going to look at other methods perhaps to communicate with those devices?
So take an example is Hurricane Florence. When we used drones for disaster response for infrastructure inspection, drones have the capability of live streaming. And the benefits of live streaming is that agencies like us, the data that we want, like our engineers want to know what's the condition of the bridge or what's the condition of that road. It takes anything from a week to a month to really get that data. But for them to even plan a team to go out and fix the problem or even do something about it, it can take anything from a week to a month. While as with live streaming capabilities, we can stream that live to the required engineer or say the governor's office, and they can take the actions immediately. If the road has to be blocked because of flooding, you don't want people to go on the road. So the I-40 during the Hurricane Florence was shut. That image that was circulated nationally and internationally was the picture that we took. Our team went out there, no one knew the condition of that road, and we took a picture, we did a live streaming. Now that was good because there was connectivity there. But when we went to certain areas, we couldn't do live streaming. So we had to, take the video, and the video connectivity also is pretty poor because it uses a Wi-Fi connectivity. And then by the time we got the data, it was a day, 2 days. So this is where, you have areas that perfect. That's your comfort zone, like Ismail mentioned. In your university, you have everything you want. Moment you get out in the real world, there are so many factors. Weather's the biggest factor, and if you want reality of urban air mobility and vehicles moving, we need to understand weather better. You have areas that are within the city between two buildings that the weather pattern shifts. And if you don't know the condition at that place, that's a problem. And then the whole thing comes as automation. We are talking about moving into automation, and we're not just talking about aerial vehicles. We're talking, if you talk about smart agriculture, you have your dozers talking to the drones and giving you live 3D maps. And when you are operating such heavy heavy systems and expensive systems, you want the right information to come through. And then comes the part about removing the human element out of certain technologies. It's in the manned side. There's been a long discussion that you want to remove the second person from the cockpit because it can be run by one person, and it's not been possible. It's still in progress, but it's not the reality. So that's where connectivity in your own comfort zone for us, where we know it's good, we are successful always. But the moment we start getting out, that's the reality of where our program is and what sort of help we need. And I think that's where first responders, same thing. We work with first responders, and you want them to get the data or them to use this technology at areas where there may be no cell tower. Maybe you have to, I think I read most recently, it was in the Caribbean islands, I think it's last year, they used a drone to provide connectivity. And I think it was AT&T was the one tested it out. That's the thing, that's the reality. Even Facebook at one point was testing out their drone that could give connectivity at remote areas. So the research has been going on, but it has come through roadblocks. And I think this is also the reason why was because people did not work together. The private sector was doing their stuff, the research, but it did not come out. And I think here, the public-private sector working together, NCDOT, a traditional agency that wouldn't be doing this, if in other states, are now getting involved in deep research.
I want to add one thing too, because I'm so glad you asked the question about non-urban environments. AERPAW is the third test bed in this program. The fourth one, and the RFP process is going on right now, is focused entirely on rural broadband and the idea of what innovations can help bring down the cost curve for getting better connectivity in rural environments. That process is going on now. That new test bed will be announced in 2020. And ultimately, over time, the goal is to have the different test beds and the different research teams learn from each other. So the things and the lessons that are learned, about drones and public safety and the focus down at AERPAW can also be translated and used in conjunction with the things that are learned from some of the technologies and processes that are tested to try to bring down the cost of deploying some of this connectivity in rural environments.
So we have time for about one more question. Go ahead.
One last question. Will the FDA allow data encryption for the software-defined radios? Currently, that hardware has been banned from being sold anymore in the U.S. for encryption of software-defined radios. So going forward, that means that if they're using it for these tests, they will not be able to incorporate data encryption for that, for security, as well as reliability or disaster recovery.
I'm not sure if I got all the question, but so software-defined radios will be one part of our platform. We will be supporting other IoT and 5G equipment. So for testing purposes, I think the encryption and security, we are working with the PAWR project office and other platforms. They already have some mechanisms in place. We will be adding those as well. So our main goal will be having these platforms accessible to researchers to test new waveforms, new technologies, new algorithms, and we will be working with also our leadership for the security and framework. For example, for Mary mentioned about this FCC innovation zones, so we are allowed, we are applying to that as well. We will be allowed to transmit on certain frequencies. Obviously, the experimenter may do anything, it may change the frequency, but as we have mechanisms in place to detect those type of efforts, they're already in place in the Utah platform, for example, and we will shut down the platform. If a drone is going outside of a geofence, we will bring it down immediately. So we are thinking about all the safety mechanisms and security, so we hope we will address all those concerns.
And I would add to this, I think, and you guys can correct me if I'm wrong, with these experimentations, part of it is getting that data, sharing that data to the policymakers and the regulators to say, we need those security pieces, we need that in place, and so maybe that can change regulations and legislation and those things to drive that. So. All right, well, that's going to wrap up our panel today. I want to thank my colleagues here. It's been great, bit of information about this, and I want to thank you guys for sticking around and listening to this exciting project that we're embarking on. And I guess we're off to lunch now.